Welcome to the Deep Dive for Factory English, Episode 1. Today, we're going to talk about a serious topic, downtime in manufacturing.
Oh, yeah, it is a huge topic.
Right. And, what if I told you that intentionally turning your factory machines completely off is actually the secret to producing more goods?
I mean, it sounds crazy.
It sounds like a total contradiction.
Right.
But understanding why that works is really the key to mastering how a production floor actually operates.
It really is. And if you work in manufacturing, understanding that paradox isn't just about some high-level business strategy. It's about survival on the factory floor.
Exactly. And that brings us to our mission for this deep dive today, because this is custom designed for you, the listener.
Mm-hmm.
If you're learning English as a second language and you're working in the manufacturing field, we know the challenge you face. You don't just need, textbook definitions.
No, nobody talks like a textbook out there.
Right. You need plain English. You need the everyday workplace vocabulary, the actual phrases people are shouting over the roar of a stamping press.
Yeah.
Our goal is to get you confidently discussing these concepts out there on the floor.
Which is why we're taking a short foundational text about downtime today, and we're just going to pull it entirely apart.
Yeah.
To give you a high-level summary before we jump in, this text defines what it means when a factory stops making its goods. It uses this really relatable example of a smartphone factory to show us the mechanics of that stoppage.
Super helpful example, yeah.
Right. And then, crucially, it divides these work stoppages into two distinct worlds. So, the pauses we carefully plan for and the absolute disasters that catch us completely by surprise.
Okay, so to make sure we are both working from the exact same blueprint, we're going to read this short text aloud first.
Yeah, let's do it.
We'll trade off sections. So listener, just listen along, get the rhythm of the words, and don't worry about catching every single nuance quite yet. We'll unpack all the underlying mechanics right after. So here we go. In the manufacturing world, downtime refers to any period when a machine, production line, or even an entire factory ceases to produce goods.
Think of it like this. If a factory is supposed to be making smartphones, but a machine breaks down, the time it takes to fix that machine is downtime. If they need to change the production line to make a different type of smartphone, the time spent setting up the new process is also downtime.
There are two main types of downtime.
Planned downtime. This is when a factory intentionally stops production for things like scheduled maintenance, equipment upgrades, or to change over the production line for a new product. It's a necessary part of keeping things running smoothly in the long run.
Unplanned downtime. This is when something unexpected happens that stops production, like a machine suddenly breaking down, a power outage, or even a shortage of materials. This type of downtime is usually more disruptive and costly.
Essentially, any time a manufacturing operation isn't actively producing, it's considered downtime.
All right, so setting the baseline here, the text opens by defining downtime as any period when a machine ceases to produce goods.
Right, ceases.
Now, ceases is one of those words that makes perfect sense when you're, sitting in a quiet office reading a manual.
Yeah, it simply means stops. It's a very standard, formal English word.
But imagine I'm actually out there on the floor. I'm wearing a hard hat. I have my foam earplugs in. There are forklifts driving by. If a conveyor belt suddenly jams and I run over to my shift supervisor and shout, "Excuse me, the machine has ceased to produce."
They are going to look at you like you just stepped out of a 19th century novel.
Exactly. Nobody talks like that when things are moving fast.
They absolutely do not. And while that is the crucial gap between academic English and practical, boots-on-the-ground factory English. On the floor, language is driven by urgency and, brevity. You need to communicate the problem instantly. So instead of ceases, you want to use common collocations, words that naturally pair together in a workplace environment.
Right, like what should I say instead when a machine just quits working?
Well, you might hear someone yell, "We have a production stop," or, bring to a halt. But the most common, universally understood phrase you will hear, and the one you should definitely adopt, is line down.
Line down. Wow, that's incredibly efficient.
Yeah, it really is.
It's two syllables, and it tells everyone exactly what the stakes are.
Exactly. "Hey, boss, we've got a line down." It instantly communicates that the flow of goods has ceased, and it triggers an immediate response from the maintenance team.
So establishing that boundary of what a line down means is great. But the text doesn't just leave it at that abstract definition. It moves into a practical scenario with the smartphone factory.
Right.
And what stood out to me there is that it paints two entirely different pictures of a stopped line.
Yes. The text presents two very specific, contrasting scenarios. Let's look at the mechanics of what's actually happening in the factory in both of them.
Okay.
In the first scenario, a machine making smartphones breaks down. So the time spent fixing it is downtime.
Makes sense.
But in the second scenario, they are changing the line to make a different type of smartphone, and the time spent setting up the new process is downtime.
So in both cases, 0 smartphones are coming off the conveyor belt.
Right.
But the reality for the workers standing there is totally different. Let's start with the breaks down scenario. What's the real workplace vocabulary when a machine just refuses to cooperate?
So while broken is understood, it's often way too vague for a technical environment. On a modern factory floor, machines are highly computerized.
Oh, sure.
So you will frequently hear the words malfunction or fault.
Of fault. Okay.
Yeah, fault is a great word to know. A machine might not be frankly smashed to pieces, you know? Maybe an optical sensor just has a tiny speck of dust on it.
Wow, really? Just dust.
Just dust. The computer reads that as an error, stops the line, and throws a fault code on the screen. So you'd say, the robotic arm is showing a fault.
Okay, that makes sense. A fault or a malfunction. But what about that second scenario? The text calls it setting up the new process.
Mm-hmm.
Say we were making the standard smartphone yesterday, but today management says we need to make the larger Pro version of the phone. The machines aren't broken, but they have to be adjusted. What do we call that?
Well, the professional term for that is retooling or an equipment changeover.
Retooling.
Yeah, and this is a massive operation. When you are retooling a line, you aren't just pushing a single button. Technicians are physically swapping out the heavy molds that shape the plastic.
Oh, wow.
They are recalibrating the robotic arms to reach an extra half-inch because the new phone is bigger. They're loading entirely new software programs into the system. It can take hours.
Right.
So you wouldn't say we are setting up. You would say, the line is down for retooling today, or we're doing an equipment changeover.
You know, thinking about that difference, a machine throwing a fault code versus a planned equipment changeover, it makes me think about, like, a vacuum cleaner.
Okay, let's follow that logic. How does a vacuum cleaner explain smartphone manufacturing?
Well, think about the actual work of vacuuming your living room carpet.
Yeah.
As long as you're pushing it back and forth and dirt is going into the canister, you are actively producing a clean floor.
Right.
But then you get to the corner of the room and you need to clean the baseboards. You have to turn the vacuum off, pull off the wide floor roller, and snap on that narrow little crevice tool.
Ah, I see. You have to completely stop the primary function to adapt the machine.
Exactly. While I'm wrestling with those attachments, I am not cleaning the floor. The machine is off. That time is technically downtime.
Yes.
But I haven't broken the vacuum. I'm just retooling it for a different process. Contrast that with me pushing the vacuum and suddenly the motor starts smoking and catches on fire.
That's a fault.
Right, that's a malfunction.
That is a fantastic way to visualize the underlying mechanism here. And what your vacuum analogy reveals is a massive difference in intent.
Intent, yeah.
When the motor catches fire, that's an accident. You have zero control over it. But when you turn it off to change the attachment, you are entirely in control. It's purposeful. And that idea of intent brings us directly into the two major classifications the text outlines.
Right, the text splits the universe of downtime into planned and unplanned.
Mm.
Let's dive into planned downtime first. The text says this is when a factory intentionally stops production for things like scheduled maintenance or equipment upgrades.
Intentionally is the anchor word there. Let's expand on the term scheduled maintenance. In plain English, maintenance is just the regular care that complex physical objects need to survive.
Right, like taking care of it.
Exactly. On the factory floor, you'll hear this referred to as a routine check, or more formally, preventative maintenance. You might even see the abbreviation PM on a whiteboard. Like, we have a PM scheduled for the hydraulic press at 2 p.m.
Preventative maintenance, meaning we're trying to prevent a disaster before it happens. And the text also mentions upgrades.
Yes. That could involve calibration. Calibration is a vital piece of factory vocabulary.
What does that entail? Exactly.
Well, it means making tiny, precise adjustments to a machine so it measures, cuts, or weighs perfectly accurately. If a machine cutting glass for smartphone screens is off by just a millimeter, thousands of screens will be ruined.
Oh, man.
So you intentionally stop the line to recalibrate the laser.
Okay, I understand the vocabulary, but I really have to push back on the text's core argument here.
Okay, pushback.
The text makes this incredibly bold claim that stopping production is a, quote, necessary part of keeping things running smoothly in the long run. Wait. If the whole goal of a factory is to make things, how can turning the machine's OFF be necessary? Doesn't that directly hurt the company's profits? It feels counterintuitive.
It is the ultimate manufacturing paradox. To understand why it's necessary, you have to think about what is happening at a microscopic level inside these machines. We are talking about heavy gears, metal belts, and industrial motors spinning at thousands of revolutions per minute.
Right, it's a harsh environment.
Incredibly harsh. All of that movement generates immense friction and blistering heat. If a manager decides, we are never stopping, keep the line running 24/7 to maximize profits, well,
Things go bad.
very bad. The lubricating oil inside those motors will eventually burn away. The gears will start grinding metal on metal. The heat will rise until the internal components literally melt and fuse together. The machine just destroys itself.
Ah, okay. So you sacrifice 1 hour production today, intentionally, so you don't lose 3 weeks of production next month when the entire assembly line melts down.
Precisely. You are trading a small, controlled loss of time for long-term survival.
It's like running a marathon. Planned downtime is kicking your car. Wait, no, a marathon. Planned downtime is intentionally stopping at the water station at mile 10.
Right.
You lose maybe 30 seconds off your race time, but your body gets the hydration it needs. Unplanned downtime is skipping all the water stations to save time, and then tearing your hamstring at mile 20 because your muscles cramped up.
That is the perfect metaphor. Stopping at the water station is an investment. Tearing your hamstring is a catastrophe. And that catastrophe is exactly what the text describes next, which is unplanned downtime.
Let's get into the dark side of manufacturing,
Oh, yeah.
the stuff that gives plant managers ulcers. The text describes unplanned downtime as when something unexpected happens, and it lists 3 specific nightmares. A machine suddenly breaking down, a power outage, or a shortage of materials.
Let's translate these disasters into the language you'll actually hear when the alarms go off. We already discussed faults and malfunctions for machines breaking down, but what about a power outage?
Yeah, what's the term there?
In everyday English, the electricity goes off, but on the factory floor, you'll hear people say, "We lost power," or, more commonly, "The grid went down."
The grid went down.
Yeah. If you hear the grid is down, it means the external power supply to the entire building has failed.
So everything goes dark. Total silence.
Exactly. Now, the third example is fascinating, a shortage of materials. This is a completely different kind of nightmare.
How so?
Well, the power is on, the machines are working perfectly, but you have absolutely nothing to feed into them.
Oh, wow. So the machine is ready to stamp out the metal phone case, but there is no metal. What's the workplace phrase for that scenario?
You'll frequently hear operators say, "We're running out of stock," or "We're out of raw materials." But if you want to understand the larger business mechanism at play here, you need to know the term supply chain delay.
Supply chain delay.
Yes. Modern manufacturing often runs on what's called a just-in-time system.
Right.
Factories don't want to pay for massive warehouses to store thousands of parts. They want the delivery truck to arrive with the smartphone microchips exactly 1 hour before the line needs them.
Which is super efficient, right?
Incredibly efficient.
But also incredibly fragile.
Extremely fragile if there's a snowstorm or, a customs issue at a port, and that truck of microchips is delayed by 4 hours, the entire factory floor grinds to a halt. You have a supply chain delay causing massive, unplanned downtime.
And the text makes a point to describe this unplanned downtime as disruptive and costly, which makes total sense when you think about the stakes. Going back to the marathon analogy, tearing your hamstring isn't just a brief pause. You need a medical tent, you need physical therapy, you might not race again for months. It derails everything.
And in a factory, the costly part is very literal. It's not just the cost of fixing the broken machine or paying extra for expedited shipping on missing parts. The true cost is the overhead.
Break that down for me. What do you mean by overhead in this context?
Overhead means all the fixed costs of running the business. Imagine a factory floor with 300 workers. Suddenly the grid goes down, or you run out of stock because of a supply chain delay. The machines stop. But the company's expenses do not stop. They are still paying the hourly wages of those 300 workers who are now just standing around waiting.
Oh, geez.
They are still paying the lease on the massive building. They are still paying the baseline utility bills. Their costs remain at 100%, but their output has dropped to absolutely zero.
Wow. It's just a financial hemorrhage.
It was a silent profit killer. Every minute of unplanned downtime is pure lost revenue.
That reality makes the final summarizing rule of our text so impactful. Let's look at the bottom line. The text concludes by saying, essentially, Anytime a manufacturing operation isn't actively producing, it's considered downtime.
The phrasing to really latch onto there is actively producing.
And that actually brings up a huge question for me. Let's say I'm an operator. My machine is turned on, the power is flowing, the control panel is lit up, I can hear the hum of the motor.
Okay.
But because of that supply chain delay we just talked about, I'm just waiting for a bin of parts to arrive. The machine is technically running. Is that still downtime?
Yes, it absolutely is. And this is a very common trap to fall into. Being powered on is not the same thing as actively producing.
Right.
Actively means the physical transformation of goods is happening right now. If the machine is humming, but no finished product is coming out the other end, it is downtime.
That is a crucial distinction. Is there a specific word for that state, when the machine is awake but doing nothing?
Yes, there is a very specific essential piece of vocabulary for this. When a machine or a worker is available and ready, but not currently doing productive work, we call it being idle. I-D-L-E, idle.
Machine is idle.
Exactly. You'll hear supervisors say, "We have too much idle time on line 4.
I bet they hate that.
Oh, they do. Idle time is one of the most frustrating forms of downtime because nothing is technically broken. It usually points to a failure in planning, like a supply chain delay or bottleneck where one machine is working too slowly and forcing the next machine to just sit idle waiting for the parts to arrive.
It goes right back to that idea of the silent profit killer. You're paying the electric bill to keep the machine humming, and you're paying the operator to stand there, but you're getting zero value in return. It's fascinating how a simple concept like stopping unfolds into all these complex layers of efficiency, mechanics, and finance.
It really is the heartbeat of manufacturing. If you control the downtime, you control the success of the factory.
So let's zoom out and summarize the core takeaways from our deep dive today. What do you, our listener, need to carry with you onto the factory floor?
Yeah, let's review.
First, we learned that downtime isn't just about broken gears. It is any period where goods aren't being actively made, even if a machine is powered on but just sitting idle. Second, we upgraded our vocabulary from textbook English to real floor English. You don't say a machine ceases.
No, you announce a line down.
Right. You recognize that changing parts is an equipment changeover or retooling. And you know that regular checkups are preventative maintenance.
And third, we learned the critical difference in intent. We have planned downtime, those controlled intentional stops like calibration or maintenance that prevent the machines from destroying themselves.
Right.
And we have unplanned downtime, the sudden power outages, faults, or supply chain delays that bring the whole floor to a grinding, incredibly expensive halt.
Exactly. The controlled stop at the water station versus the torn hamstring. Now, we don't just want you to memorize this list. We want you to use the factory floor as your own personal immersion classroom. Starting tomorrow, try a little experiment. While you are working, actively listen to the native English speakers around you.
Yes, tune your ear to the environment. When the line stops, listen to the shift supervisors and the technicians. Do they use the word fault? Do they talk about a supply chain delay?
Yeah, notice the tone, too.
Yeah. Exactly. Notice the emotional tone. Are they calm because they are doing a scheduled equipment changeover? Or is there a sense of panic because it's an unplanned line down? Connecting the vocabulary we discussed today to the real-life stress and action of the floor is how you truly lock this language into your brain.
It's all about making those real-world connections. And to wrap up our time together, I want to leave you with one final thought to ponder during your next shift. We talked a lot about the big, dramatic examples of downtime today. But think about your own individual routine. Look around your own workplace tomorrow. What tiny, almost invisible planned downtime tasks are you executing every single day?
Oh, that's a great question.
Maybe it's taking 30 seconds to wipe dust off an optical sensor. Maybe it's double-checking that a bolt is tight before you turn the power on. Consider how those brief, intentional pauses you take are secretly the exact things saving your entire team from a massive, costly, unplanned downtime disaster. Because the ultimate lesson of the factory floor is this: the downtime you plan for is the only thing protecting you from the downtime you don't.